Hello students, I am Mr. Adinath D. Badar, Assistant Professor, Department of Chemistry, late Pushpadevi Patil, Arts and Science College, Resort, Dist, Washington. Now, today's lecture, we will discuss the ionic bonding in chemical compounds. So, firstly, we discuss the contents of this chapter. So, first contents is definition of ionic bond, types of cation, factors affecting on ionic bond formation, electron affinity, Bohr-Land equation, how to calculate lattice energy. After that, Born-Haber cycle to determine the lattice energy, solvation and solvation energy, determination of solvation energy, solubility of ionic solid, lattice energy and solvation energy. So firstly, we see the definition of ionic bond. So simply, in any ionic compound, ionic bond is formed when there is actual transfer of one or more electron from outermost energy cell of one atom to the outermost energy cell of the other atom. The atom from which the electrons are transferred acquire positive charge, and the atom which gain the electron acquires negative charge. Thus, the electrostatic attraction between the oppositely charged ion, that is positive charge ion and negative charge ion, result in the formation of bond is called as ionic bond. An ideal example of ionic bond is between sodium and chloride. So ionic bond is a simple attraction between positive and negative ion. Now firstly we see what is the ions. So elements within each group of the periodic table behave similar because they have the same number of valence shell electrons. So first we discuss what is meant by valence shell electron. So valence shell electron are the electrons in the highest occupied energy level of an element or atom. Valence electrons determine the chemical properties of elements. Now we see how to find the number of valence shell electron. So to find the number of valence electron in an atom of a representative element, simply look at its group number. Group's number is equal to the number of valence shell electrons. Now the next concept is octet rule. So firstly we see the definition of octet rule. So simply, in forming compounds, atoms tends to gain or lose electron in order to achieve the electronic configuration of a noble gas, that is the valence shell having 8 electrons. Here we see the some examples of octet rule. Here these are the hydrogen atom having one electron. These are carbon, nitrogen and oxygen. Here in hydrogen the valence shell having one electron. Here in carbon the total atomic number is 6 and valence shell having 4 electron. 1, 2, 3, 4. Here nitrogen atomic number is equal to 7 and the valence shell having 1, 2, 3, 4, 5 electrons. In that oxygen, here the atomic number is equal to 8 and the valence shell having 6 electrons 1, 2, 3, 4, 5, 6. In the carbon atom, for the completion of octet, 4 electrons are required. That is, to attain the octet, carbon must gain 4 electrons to gain a octet or to gain 8 electron in valence shell. Here nitrogen already have a 5 electron in valence shell, so it prefer to gain 3 electrons to get a octet. In that oxygen, the valence shell already carries 6 electrons, so only 2 electrons are required or to gain to achieve the octet in valence shell electron. Octet rule: atom tend to gain or lose or share electron so as to have 8 electron in valence shell. Some important concept of ionic bonding is atoms of metals lose their valence electrons. Atoms of some nonmetals tend to gain electron or to share with other nonmetallic elements to achieve a complete octet. So simply, metal always prefer a loss of electron to gain a positive charge, and nonmetal always prefer to gain of electron to acquire a negative charge. These are the important concepts in ionic bonding. Always metal shows or carry positive charge by loss of electron, and always non-metal shows negative charge by gain of one or more electron. So we discuss what is the ionic bond. So simple, the electrostatic attraction between cations and anion is known as ionic bond. So firstly we see formation of cation or how to form cation. When an atom losses of electron, it produces a positively charged ion and it is called as cation. When any atom loss one or more electron to produce positively charged ion, and this ion is called as cation. The most common cations are those produced by the loss of valence electron from metal atom. Here for example sodium. Sodium atom electrically neutral, charge is equal to 0 at atomic state. If loss of valence electron, that is, this step is called as ionization. To give Na plus, sodium ion plus sign indicates one electron loss, and to gain a positive charge plus electron minus sign indicates the 1 unit of electron. Here these are the example. Na at atomic state charge is equal to 0, but after a loss of 1 electron it gains positive charge. Plus electron. These are the example of cation. Always prepare loss of electron due to it is metallic, and after the loss of 1 electron, it achieves the 8 valence shell electron or 8 electrons in valence shell. That's why it always prepare loss of 1 electron. Now here the electron dot structure for sodium ion. Here sodium having 11 proton and 11 electron in atomic state. After loss of 1 electron, it have 11 proton in nucleus and 10 electron in valence shell. That is, sodium at atomic state charge is equal to 0. After the loss of 1 electron, it turns into Na plus and carry plus 1 charge. Sodium atomic number is equal to 11. That is, these are the electronic configuration: 1s2, 2s2, 2p6, 3s1. one valence shell electron. Removal of electron from ion, that is loss of 3s1 electron, to give here atomic number is equal to 11 but number of electron is equal to 10, 1s2, 2s2, 2p6. Here the valence shell is 2s and 2p, means 2 plus 6, that is in Na plus the valence shells carry 8 electron, that is to attain the octet. In atomic state the valence shell electron carry 8 electron, carry 1 electron, that is not fulfill the criteria of octet rule. For that, to attain octet, sodium always prepare loss of 1 electron to achieve the 8 electrons in valence shell. Now has full shell with similar electronic configuration to neon as stable, means easily achieve the next noble gas electronic configuration. Now next we discuss formation of anion or how to form anion. So simply the gain of negatively charged electron by a neutral atom produce an anion. So simple, anion is formed by gain of one or more electron. Here these are the example: chlorine atom plus 1 electron, gain of 1 electron to gives chloride ion, that is Cl minus. Here the electronic configuration of chlorine: 1s2, 2s2, 2p6, 3s2, 3p5. After gain of 1 electron, this electronic configuration turns, that is 1s2, 2s2, 2p, 2p6, 3s2, 3p6, 3p6. Here the valence shell carries 5 plus 2, that is 7 electron. After the gain of 1 electron, these 7 electrons are turned into 8 electron, that is 3s2, 3p6, that is fulfillment of octet rule or achievement of 8 electron in valence shell. That's why chlorine atom always prefer to gain 1 electron to achieve 8 electrons in valence shell. Now here the electronic dot structure of chlorine ion, chloride ions. Here chlorine atom having 17 proton in nucleus and 17 surrounding electron. Gain of electron, proton must be same as like atomic state, but electrons are changed, that is 70 is converted into 18 after the gain of 1 electron. Here chlorine atomic number is equal to 7, that is here electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5, means the valence shells carry 7 electron, that is 3s2 plus 3p5, 5 plus 2 is equal to 7 valence shell electron. After the gain of 1 electron, it gives chloride ion. Chlorine atoms is converted into chloride ion, that is atomic number also 17, but the electron or number of electrons are changed. Here 1s2, 2s2, 2p6, these are the inner shell. Here the valence shell 3s2, 3p6, 6 plus 2, that is 8 electron. 8 electrons in valence shell, that is fulfillment of octet or 8 electron requirement. Valence shell now has full shell with similar electronic configuration to the argon, that is noble gas or next noble gas after the chlorine